Hi everyone. Today we are starting on page number 52 and we are going to be talking about transport into and through the cell. So the first type of transport that we're going to be talking about is diffusion. So let's title this. And we've talked about diffusion quite a few times already, but now we're going to actually define it and give some examples. So diffusion is the random movement of molecules So that's going to mean, because it's random, there's no actual energy required into making this occur. And the random movement of molecules moves from areas of high concentration to areas of low concentration. So this is a passive type of movement. That means that there's no energy required. So let's just add that in here. So this is passive. No energy required. So let's give an example of this. So my example for this is going to be spraying like a Febreze or a perfume. So I'm going to draw here a very high-tech bottle because my artwork is so good. We'll put a label on it. And this bottle, when I spray it, it's going to make a cloud of stuff. Sure. And if I look at one sort of area here, if I were to zoom in on that, my zoom in would show me that I have a lot of molecules of whatever this spray is, my Febreze, my perfume, my Axe body spray. Don't use too much of that. So we're going to make a little psst sound. I have no idea how to spell that. And this is a high concentration. So here I have a high concentration. And if I were to spray this, over time, my high concentration molecules are going to move and they are going to spread throughout the room. But my overall movement, my net movement, is going to be from this area of high concentration towards my area of low concentration. So if I look at a zoom in of the air over here, we'll do our same little box setup. In this one, I might only have like 4 particles, 4 molecules of this, because this is my low concentration. So the net movement is from high concentration to low concentration. So are some of these molecules going to be moving backwards? Yes. Are some of them going to be moving up or down or closer into this little cloud? Yes. But overall, they are going to be moving from this area of high concentration towards this area of low concentration. And the purpose of this is so that they reach something called equilibrium. So we're going to add a little bit more to this. So we're going to just give ourselves a little note here that molecules move and then we use different words for this. Sometimes we say that they move down the concentration gradient. Sometimes we would say that they move with the concentration gradient, or we could say they move along the concentration gradient. So those are just a couple of different options. And those could come up on a test. How do you spell concentration? I feel like I'm doing it wrong. You guys fix this if this isn't right. So down the concentration gradient until equilibrium is reached. So let's talk about what a concentration gradient is. So give myself a little label here. I really hope I'm spelling that right. If not, it's on you guys. You can Google it. I can't pause this. Doesn't save it in the right format, so you're on your own. All right, this is going to be an example of a concentration gradient. So concentration gradients means that there's more molecules in one location than another. So I'm going to start with it being a high concentration on this side. So I'm going to start by making a whole bunch of dots that represent my molecules. And they're sort of randomly dispersed, but this is pretty concentrated. And then as I get closer to this side, I'm going to have a very dispersed set of dots. Now they're getting a little bit closer together. And then even closer together. And then as we get over here, this is where it's super concentrated. So I'm going to have a whole bunch of dots. And I'm just going to keep adding a few. You can see that as we get closer to this far side, we have fewer of those dots. If I want to make it really obvious, I can even just keep adding more on this side. The more I add, the higher the concentration is, and the more variation that I have. So this is my area of high concentration, and this is my area of low concentration. And that's a gradient. So it's sort of like when you make your hair ombre and it goes from one color to the next, or in this case, it goes from high concentration to low concentration. Equilibrium is when you have them evenly dispersed. So if these move along the concentration gradient from high to low, then it's going to do that until equilibrium is reached. So I would have the same number of molecules here, but there's going to be the exact same amount of space between them. And once equilibrium is reached, the molecules are still moving, but you have an equal number moving this direction as you do moving this direction, an equal number moving up as are moving down. So let's add another note here that once equilibrium is reached, the molecules still move, but there is no net movement. The molecules are equally spread out. All right, that is standard diffusion.